Hi, I'm Neil deGrasse Tyson, your host for Nova Science Now. You say you wish you were in better shape?
Why don't you just go ahead and I'll catch up with you later.
But like this guy, you'd rather crunch your chips than your abs? Well, hold on to your treadmill, because this geneticist has found a drug that's turned a couch potato mouse into a long-distance runner.
This mouse we call the marathon mouse.
Exercise in a pill? How did he do it? And could it ever work for you? Also, how did the dinosaurs really die? Was it that giant rock from space?
Wow, Roberta, look at this.
Or something more down to earth?
What we've done is to present a different theory.
The answer might be hidden in, what's this? Dinosaur poop?
Yes, fossilized species from dinosaurs. We actually call them coprolites.
And in this episode's profile, you'll meet a rocket scientist who sees himself as a modern-day Spock.
Mr. Spock is a scientist, but he also flies.
And so does this astronaut, who's been to space more than almost everybody. He's also designed a faster rocket to boldly go where no spaceships have gone before.
We will have the entire solar system at our disposal. Humans will be inhabiting space in a big way.
All that and more on this episode of Nova Science Now. Everybody knows exercise is good for you. It's great for your heart, good way to stay trim. Some people just love doing it. But for others, it's just too hard. There's all that trouble, all that sweat. Then, of course, there are people who can't exercise because of illness or injury. Correspondent Zaya Tong met some researchers who have discovered a drug that may someday allow those people to get the benefits of exercise without having to do the work.
When I watch something like the Boston Marathon, I'm blown away. These people are like Energizer bunnies. They keep going and going, and they're so lean. How do they do it? They'll all say, by training. But what if you could skip all that? What if there were a drug that could miraculously give even the laziest slob a lean, buff bod and turn them into an endurance athlete? It sounds like the ultimate couch potato fantasy. Well, it's no fantasy to this guy. Ron Evans from the Salk Institute figured out the secret formula and gave the magic potion to a mouse. And just like that, a couch potato mouse was transformed into a real marathoner. It all started with Evans' fascination with endurance. Only some animals have it. Horses have endurance, and so do migratory birds. But our closest relatives, all the other primates, don't.
In fact, humans are the only primates that have endurance. You don't see gorillas going on marathon runs, and the other primates aren't really designed for long-distance running. Humans are designed to be good runners if we want to be good runners.
Glenn Mays is a good runner.
I've been running for a very long time. I started when I was a young kid, and I had kind of a knack for it.
I don't know how much longer I can really. Glenn has such a knack, he won the Little Rock, Arkansas Marathon. Are you tired yet?
No, not yet.
And me, not so much knack. Why don't you just go ahead and I'll catch up with you later? Of course, Glenn works much harder than I do.
Spent a lot of time just getting in the miles and doing long runs and being on your feet for 90 minutes, 2 hours, 2.5 hours.
And all that effort has changed Glenn's muscles. There are two main kinds of muscle. Folks like this build up the bulk with what's called fast twitch muscle. It contracts fast and strong and gets its energy from a particular kind of fuel source, sugar.
most muscle likes to burn sugar. So power muscle burns sugar.
But if you could look inside the body of someone with endurance, say inside the legs of Glenn Mays, you'd see slow twitch muscles. These can keep going for much, much longer because the fuel they burn is something much higher octane than sugar.
Endurance muscle burns fat.
When it comes to fat, a little bit provides a lot of energy. Most people can train their bodies to burn more fat, but they've got to work at it.
Exercise is what usually promotes that fat burning, but we don't get enough exercise. So we wanted to see if we could actually trigger the process even in absence of exercise.
So, Ron Evans went on the hunt for a way to rev up the fat burning in a muscle without making it exercise. He honed in on a key gene, one that can turn on lots of other genes.
We're looking at a master regulator. It's sort of a genetic switch. If you're able to switch it on, you will activate a network of genes that allows you to burn fat.
Evans figured out how to turn on this fat-burning genetic switch inside a mouse embryo, so it would work in overdrive. And then he watched the genetically engineered mouse grow up. It was definitely more svelte.
And indeed, the mouse that was generated from that does burn more fat. It's slightly thinner, and we liked the way in which the mouse was looking.
But this mouse was a lot more than good looking.
If you put it on a treadmill, it can run the pants off any other mouse. And so while the other one had been exhausted, thrown back at the treadmill, this mouse was running for another hour. And this mouse we call the marathon mouse.
By manipulating just one genetic switch in the embryo, Evans created a mouse with fantastic endurance. How's that possible? It turns out the switch Evans turned on set off a chain reaction that directed the mouse to make more slow twitch muscle. Slow twitch muscle is especially packed with things called mitochondria. Mitochondria are little factories inside our cells that turn sugar and fat into energy. And in the marathon mouse, the mitochondria were burning more fat than usual. The mouse's muscles and metabolism were completely transformed, as if this little guy had been exercising his butt off. All because Evans turned on one little switch in the mouse embryo. A mouse that could run almost twice as far as an ordinary mouse made science headlines and had very interesting implications for people. After all, who wouldn't want the ability to run that extra mile? The problem was these mice were programmed as embryos to be superstars, and we don't do that to human beings, at least not yet. So Ron Evans started searching for a drug that could activate that same marathon gene. But as he soon found out, it's not that easy. When Evans tried to use a drug to turn on the fat-burning gene in an already grown-up mouse, it didn't really work. He got a mouse that didn't run any better than average. So Evans took a closer look at what happens inside our muscle cells whenever we give them a workout.
As you become more and more trained, the muscle actually starts making more mitochondria and also making them larger so that they can actually process and break down more fuels for energy.
So how does exercise tell our muscles to make more mitochondria? Evans saw that during exercise, as energy gets consumed, certain chemicals build up in the muscle cells and trigger the cell's molecular fuel gauges. When energy gets too low, they'll signal the cell to make more mitochondria and pump out more energy.
It's like the fuel gauge. We're getting onto low, we're getting near empty, let's get the gas back in the tank.
Evans decided to try a drug called ICAR that he believed would, in effect, break the fuel gauge, tricking the muscle into thinking it was running on empty, even when it wasn't running at all. So Evans got together some mice and didn't exercise them one bit.
Completely couch potato mice, all watching TV, none of them getting any exercise, and one of them was getting the ICAR drug.
ICAR was injected into the mouse's bloodstream 5 days a week for a month. And when this couch potato mouse got on the treadmill, the results were amazing.
That turned into a spectacular result. The ones that received ICAR were able to run approximately 44% longer distance.
In fact, this drug-enhanced couch potato mouse ran nearly a mile. That's almost like running a whole marathon for you and me. And when Evans took a look inside the mouse's muscle cells, the difference the drug made was striking. Look at the normal mouse's cells. The mitochondria show up as dark spots. But look at the mouse that took ICAR. Tons more mitochondria.
This looks like the muscle of an athlete.
This one drug managed to break the fuel gauge and trick the muscle into turning on its endurance genes, pushing the muscle into overdrive.
It's remarkable that the benefit of exercise alone and the benefit of the drug almost exact.
That's right. In totally sedentary mice, Evans' drug produced results identical to regular exercise. At this point, you might be wondering, where can I get some? Well, it's a bit too soon for us humans to be taking this. Though the mice didn't develop side effects, nobody really knows how it will affect people. But if it could be used safely, doctors are hopeful it could be a valuable therapy for people who can't exercise, especially for the old and frail, who can lose muscle at an alarming rate.
10 days of bed rest is equivalent to about 15 years of aging. And so oftentimes we see someone who is fully functional go into a hospital, and 5 or 6 days later they come out of the hospital hardly able to walk. A drug like this, if it helps to restore function in older people, it may make it a lot easier for them to become active, and that would be fantastic.
Ron Evans would love to see people benefit from what could be exercise in a pill. But one major concern is how this drug might be abused, especially by athletes.
Athletes have a very low threshold for looking at performance-enhancing drugs. And their real concern is not about the drug, it's whether it can be detected.
Evans has developed a test to trace ICAR in the bloodstream to discourage doping. But even if ICAR gets out there, Glenn Mays says he's one athlete who won't be taking it. Well, if there was a drug that perhaps you could take that would allow you to run further, would you take it?
I don't think I would. I don't think I would. For me, the interest and the challenge is in seeing what I can accomplish through my training. That's what keeps you motivated, and it's a big part of distance running is staying motivated to get out there every day and do the training.
He's going to stick with the old-fashioned way of improving his endurance. After all, that's the one way we know definitely works. Maybe we should all try it sometime.
Ever since we've known dinosaurs once walked the Earth, we've been debating about what could have killed them off. There have been lots of ideas kicked around over the years, like global climate change, caused by shifts in the Earth's axis, or a series of monster volcanoes. And for the last 25 years, the most popular idea has been that dinosaurs were wiped out by a giant rock from space, an asteroid that created devastation on a global scale. But as correspondent Chad Cohen reports, not every scientist is ready to blame just the rock. Some believe the giant reptiles might have been taken down by something almost too tiny to see.
At the Poinar residence in Corvallis, Oregon, the workday starts early. At least, it does for George.
He's up with the dawn. He goes down in his socks or his slippers, sneaking so he won't wake me up.
As he makes his way downstairs to his homegrown lab in the basement, he's bent on finding things that no one else has even looked for.
He gets up in the morning to make discoveries.
Oh, wow. Roberta, come and look at this.
He's just like a kid that everything is new and wonderful.
For decades, George and his wife and colleague Roberta have bucked the trends in mainstream science, painting a novel picture of life in the ancient world. Preserved in pieces of amber, they've discovered insects, flowers, even tiny animals, all trapped in time. If this sounds familiar, it was their work that inspired Jurassic Park, in which scientists use amber to literally bring the dinosaurs back to life.
It's a dinosaur.
The movie depicted a mosquito that had actually been caught in resin and then fossilized into amber. And that's scientifically correct because amber preserves things so beautifully.
Scientifically correct, at least, until Jurassic Park scientists discover something no real scientist had ever found before. A 100-million-year-old mosquito trapped in amber with dino blood in its gut. They use it to recreate the mighty creatures.
This is a movie, this is a film, this is Hollywood. They can do whatever they want. That'd be neat, if we could actually do it.
And to date, only Hollywood can. But then in 2001, George received an unusual package by special delivery. A one-of-a-kind piece of amber containing a blood-sucking insect a lot like the one in Jurassic Park. Rather than using this extraordinary specimen to resurrect the dinosaurs, he believes it could help reveal what caused their demise. Most scientists theorize that dinosaurs died out suddenly in a fiery explosion caused by an asteroid, but not George. He believes by the time of the impact, most of the dinosaurs had already died.
You ask a scientist these days and they'll say a giant rock struck Earth 65 million years ago somewhere around the Yucatan and did in the dinosaurs. But you're not buying that.
Well, the thing is that most people have kind of jumped on the bandwagon for the asteroid theory. And what we've done is to present a different theory.
Based on what he's found trapped in amber, George believes the mightiest of creatures, the dinosaurs, were brought down by the tiniest of creatures, biting, disease-carrying insects. His first clue was found in that special delivery.
We got the specimen, put it under the microscope, saw it's a sandfly. So we went to the next objective, magnified it a little bit, and then I noticed, see, there's some dark substance in the abdomen.
In all his years, he'd never seen anything like this. It appeared as if the sandfly's last meal was still trapped inside its tummy. It looked an awful lot like blood. He asked Roberta to take a look.
When I first showed her that, she said, well, you better make sure that that's blood. We've got some more work to do here.
Yep, you have your job cut out for you.
The only way to find out was to get a closer look. That meant cutting away the amber around the sandfly. It's very tricky business. In the process, he could easily destroy the tiny fossil, and maybe lose a finger too. After each cut, he polished and carefully examined the specimen.
You have to spend hours and hours and days and weeks and months turning the same specimen over.
Searching for the best angle to get a glimpse of what's inside.
You're looking through multiple layers of tissue and you have to find that window.
By cutting the amber down to within 1 millimeter of the sandfly, George found the window he needed to see this. Blood cells from what appeared to be a reptile. The discovery made him think,
If these sandflies were feeding on reptiles, certainly the dinosaurs would have been included.
While blowing up photographs of the sandfly, using an enlarger about as ancient as his amber, he made another astonishing find.
Wow, look at that.
This was no blood cell.
Roberta!
George found a microorganism inside the fly.
Oh, wow. That's amazing.
But what was it? Consulting with experts around the world, he identified it as a deadly parasite called leishmania that's still around today, killing thousands of people every year. And it's spread by sandflies. Over the next few months, he found more evidence. 10 fossilized insects carrying the same deadly parasite. Then he found this, a midge with malaria, and another one carrying the parasite for sleeping sickness. All deadly infectious diseases.
How could this be? There was an epidemic going on, a whole epidemic. The dinosaurs were probably pretty sickly.
The Poinars believe their evidence points to widespread disease among the dinosaurs. But if there was in fact an epidemic going on, that's challenging to prove. We don't exactly have dinosaur tissue to do autopsies, and bones can only tell us so much.
They suffered just like we do from things like osteoarthritis. There's much less evidence of infectious disease. It's not going to leave impressions that paleontologists can find on bone.
They did, however, leave behind another, less appreciated memento that could yield some clues about the state of their health.
So you're telling me this is fossilized dinosaur poop?
Yes, fossilized feces from dinosaurs. We actually call them coprolites.
Coprolites.
Which is a scientific word for fossilized feces.
Okay.
Not necessarily dinosaur, but this is dinosaur.
This is dinosaur.
Not many coprolites survived the ages. But in Jurassic Park, the fresh stuff was easy to find. To put this in perspective, a male elephant, the largest land animal alive today, weighs in at about 6.5 tons, and he voids, on the average, about 22 pounds 17 times a day. That's over 300 pounds in 24 hours. Not a pretty sight. Now take that image and exchange it with this, a sauropod, and he's up to 15 times heavier than the elephant. It's hard to imagine how much dung this giant dumped.
When we look at pictures of dinosaurs, we often see them tromping through really pristine fields. Actually, those fields probably would have been littered with dinosaur dung.
Piles of poop swarming with insects and likely swimming in pathogens.
And that's an environment that today would potentially cause disease.
Yes, I have no doubt that the dinosaurs did get sick.
While Karen's coprolites don't show evidence of the deadly parasites George and Roberta discovered in ancient amber, she, along with graduate student Justin Tweet, did find this.
You see these lines here? Justin found about 200 of these very distinctive tiny burrows.
Burrows Karen believes may have been made by worms. There's a thought. Dinosaurs with stomach worms.
I think the dinosaurs were carrying all kinds of pathogens with them.
They had parasites, they had bacteria, lots of viruses. Without a doubt, microorganisms impacted the day-to-day lives of dinosaurs.
That's not exactly a surprise. Everything carries microorganisms. From worms to bacteria to viruses. We, too, host a multitude of guests that use us as a source of food and shelter. Most of the time, we peacefully coexist. But as we all know, microorganisms can sometimes make us sick. But could they have caused the downfall of hundreds of species of dinosaurs?
It's unclear that we've seen, the ability of any microorganism, viral, bacterial, or otherwise, to have that level of impact.
Until recently, nobody was thinking that extinction could be caused merely by disease. That's changing.
In fact, some scientists think there's a perfect example of it taking place today, right before our eyes. Zoologist Andrew Blaustein of Oregon State University took me to a tiny pond so I could see for myself.
The scale is unbelievable. It's worldwide, and it's similar to the dinosaur extinctions, except it's happening in modern time.
And this time, it's happening to amphibians. Frogs, toads, and salamanders are disappearing at an alarming rate. Since the 1970s, over 100 species have gone extinct.
They are in trouble, big trouble.
And one of the reasons is the spread of infectious diseases.
Here's a perfect example. Here you see a little frog. This is a tree frog. And these things are getting infected by all kinds of diseases. In the same body of water where I just picked this guy up, there are these snails. That snail carries a parasite that infects that frog.
Andrew and I were often interrupted by another example.
You hear that bullfrog out there? This is not a native species to the western United States, and it carries a deadly fungus known as the chytrid fungus, and the native species right here in this pond and lake can get that fungus. As a matter of fact, every single bullfrog that we find in this area has been infected, but they don't get sick. They just carry it.
The bullfrog, like the snail, is a new resident in the pond, and the parasites they carry are seen as invaders by the tiny tree frog's immune system.
This is what George Poinar's talking about. Well, we're seeing the same thing here today. I don't think George went far enough. I think it's a lot of diseases, and not just diseases that come from biting insects, and I think he'd agree.
Graduate students Julia Buck and Catherine Searle take swabs off a tiny tree frog's belly to check for the deadly chytrid fungus. So far, over 30% of the tree frogs are infected. But even Andrew doesn't believe this extinction event is caused by disease alone. Environmental changes like global warming and pollution make animals more susceptible to getting sick.
It may not be an overt disease that kills these things. These things can have multiple insults that really mess up their immune system.
And we can apply that to what might have happened to the dinosaurs 65 million years ago?
There were massive global changes, global climate shifts. Those could have triggered disease events.
Just like the tiny tree frogs, the mighty dinosaurs world was changing. From radical shifts in ocean temperature, to an increase in volcanic activity, to an explosion of flowering plants that nourished a growing insect population. More biting insects, according to the Poinars, meant new, deadly diseases being carried to a species already struggling to adapt to change.
When any population is stressed, diseases emerge and can run rampant. These would have been completely new diseases that the dinosaurs didn't know about before, didn't have any experience with, and they wouldn't have had any immunity to them.
We may never know if the Poinars theory is right, but one thing is for certain. They've brought us closer to the fantasy world of Jurassic Park than any other scientists, and promise to keep the discoveries coming, all from the comfy confines of their basement.
We believe that insects, little tiny sandflies and ticks and mites and everything were feeding on those dinosaurs. So that really puts insects at the top of the food chain.
Wow, Roberta, look at this. It's a biting midge, and you can see the eyes and the mandibles as well.
Wow, that's really fantastic. Look at those mandibles. They get a good bite out of something. Maybe even a dinosaur.
Maybe so.
A lot of us are hoping that someday soon, people are going to board a spaceship and travel to Mars, which, on a good day, is at least 40 million miles away. Right now, that trip takes about 7 months each way. But since there's no fill-in stations or places to go shopping en route, that means you got to pack your ride with at least 14 months of supplies.
We have a liftoff.
But what if you could build a spaceship that could go much faster and make the round trip in about 3 months? Well, in this episode's profile, we meet a rocket scientist who thinks he knows how to do it. And his new rocket could shave months off of a commute to the Red Planet. Franklin Chang-Diaz loves watching Star Trek with his wife and youngest daughter.
I've been a Trekkie since I came to the United States. We watch the episodes over and over and over again.
My dad kind of passed this rule that we can't watch it without him.
Franklin's favorite character? Mr. Spock.
He has a very important position of leadership in his crew. Mr. Spock is a scientist, but he also flies.
Like Spock, Franklin knows a few things about being a scientist and a space traveler. He was NASA's first Latin American astronaut to go into space.
Liftoff of Columbia, mission 61.
He's been to space 7 times, which ties the record. And he spent the last 3 decades developing a futuristic rocket engine.
I believe that this rocket will revolutionize space travel. We will have the entire solar system at our disposal.
Franklin's journey began in the Central American country of Costa Rica, where he dreamt of becoming an astronaut.
I was probably about 4 or 5, and I took my sister at 2 or 3 in the morning, and we climbed to the roof of our house, and we sat on the roof eating grapefruits with sugar and looking at the stars. The sky was absolutely beautiful. I knew that among those stars there were other worlds, other places. And I wanted to be there. I wanted to go there.
His first step towards space travel, he built a rocket for his high school science fair.
It had a little capsule with a small mouse and a parachute. And of course, the first stage was a complete failure. And the mouse survived, which was a real triumph.
When he finished high school, Franklin was determined to become an astronaut. His father took out a loan and bought him a ticket to the United States.
And he said, look, this is all I can do for you right now. My parents never said, it cannot be done.
With only $50 in his pocket and no knowledge of English, Franklin arrived at the home of cousins in Hartford, Connecticut. He enrolled in high school, worked hard to learn English, and let everyone know he meant business.
I decided that I would wear a tie and a jacket every single day. And so my teachers were actually a little bit surprised to see this boy come into school with a tie and jacket with some weird dreams about going into space.
His hard work paid off, and he won a full scholarship to college. Within 4 years, Franklin had started a family and was a graduate student at MIT, studying nuclear fusion and developing concepts for an experimental rocket engine.
The idea began as a result of my PhD thesis. It was clear to me that chemical rockets, the conventional rockets that we have been using all along, were not really going to give us the capability to travel far, to Mars, to Jupiter.
He was on the road to building his first real rocket when in 1977, NASA issued a call for a new group of astronauts. 3,500 would apply, only 15 would be chosen. Franklin was one of those 15.
Cuando me llamó, yo era tal la emoción que gritaba, ¡ay, lo logró, lo logró! Y mi esposo lloraba con lágrimas, pero no podía hablar. Yo fui la única mujer en el país que fue la mamá de un astronauta. No hay otra.
T-minus 20 seconds.
What I had prepared for my entire life
T-minus 12 seconds.
was actually happening.
T-minus 10. Go for engine start.
When the engines lit up, the whole thing shakes like there's no tomorrow, and you're off.
We have ignition. We have liftoff. Liftoff of Columbia in mission 61C, and the shuttle has cleared the tower. Roger, roll, Columbia.
And then, all of a sudden, everything stops. Everything floats. You're in space. Everybody rushes to look out the window. And what you see is the most beautiful thing you ever saw. And that is worth all the effort and all the trouble and all the difficulty.
Today, he shares a record for the most missions in space, and he's the most famous man in his home country of Costa Rica.
Viva Costa Rica!
It's amazing how much they react towards him. It's like he's Hercules or something.
Franklin now has privately funded labs in Houston and Costa Rica, where he devotes all of his time to testing and developing a plasma rocket engine, the same rocket he'd conceived of as a graduate student at MIT. The testing takes place inside a large steel vacuum chamber where the engine is fired. His rocket works by heating the gas argon to extremely high temperatures until the gas changes into what's called a plasma.
Typically, a conventional rocket runs at temperatures of a few thousand degrees. Sounds pretty hot, but we would like to run at temperatures of a few million degrees. Temperatures like the sun. Big difference. At those temperatures, the stuff that you're shooting is going so fast that you only need little tiny amounts of it.
That's what makes Franklin's rocket so revolutionary. It could use a fraction of the fuel used by conventional rocket engines, which could save millions of dollars in fuel costs.
So you have a very small fuel tank. You can then make a tremendous rocket that way.
In 2012, for its first field test, Franklin's rocket will be fired on the International Space Station, 200 miles above the surface of the Earth. If it works, his rocket may someday take the first humans to Mars.
If you use a conventional rocket to go to Mars, it will take you about 7 months. If you use a plasma rocket, it will take you about 39 days.
Franklin imagines a future where space travel will be like Star Trek, with no limits to where we can go.
My dream or my vision is a future for humanity where we will have the entire solar system at our disposal. Humans will be inhabiting space in a big way. I think all human beings dream. I always tell the kids I meet to follow your dreams. It's the first thing I tell them. Do not let anyone tell you that you can't do something until you find out for yourself. I'm talking about the ability of a child to say, look, I want to change the world. Go do it.
Welcome back. A breaking story tonight. Big storm brewing. We've got a meteorologist in the field. Can you hear me?
Yes. As you can see, I'm in the thick of it out here.
Excuse me, but where are you?
I'm out in space, orbiting Earth. And believe it or not, there's some serious storms up here. And they can cause all kinds of problems down there, especially with communication systems.
Seem to be having some technical difficulties. And in the meantime, check this out. Anyone who has seen the aurora borealis, or northern lights, will tell you that one of nature's most spectacular performances. A celestial ballet of light dancing across the night sky. But it turns out there's much more to this dazzling display than meets the eye. Because the same thing that powers the dance of the northern lights can also wreak havoc, exposing astronauts to deadly amounts of radiation, frying electrical systems and satellites, and overwhelming power grids, causing widespread blackouts. Problem is, no one has ever been able to agree on the exact choreography of events that gives rise to both this beauty and danger.
This has been one of the persistent and difficult questions to solve in space physics.
But now, an unusual space mission is aiming to solve this mystery once and for all. Because figuring out what makes the northern lights dance may also hold the key to predicting these kinds of events and avoiding disaster. The northern lights take place more than 60 miles above Earth's surface. But they're not caused by weather on Earth. They're caused by something much less familiar, called space weather. Now, some of you may be thinking, space weather? Can't possibly rain or snow in space. I mean, you don't see astronauts shoveling out the space station, do you? Well, turns out space has its own special kind of weather, thanks to that big ball of glowing gas we call the sun. Every day, the sun spews out 1 million tons of electrically charged particles, which race away at up to 300 miles per second, forming what's known as the solar wind. Most of these particles are deflected by Earth's magnetic field, the protective shield that envelops our planet. But some sneak through and eventually collide with air molecules. When they hit oxygen, you get a red or a green glow. Nitrogen, a blue glow, creating a steady ring of lights around the north and south magnetic poles. But sometimes, the whole process goes berserk. Huge amounts of energy from the solar wind build up in Earth's magnetic field and then are released in a sudden explosion called a substorm. And you can tell when that happens because the northern lights start to dance.
So the eruption of the aurora really corresponds to an eruption of a substorm, an energy release out in space.
But where do these violent storms begin? To find out, a team has launched a mission called Themis, consisting of 5 identical satellites. Wait a minute, 5 satellites? Isn't that overkill? Well, to see why they needed that many, think of a tsunami. A single buoy in the ocean can tell you if a tsunami has taken place. But if you want to figure out which way the wave is moving and how fast, you need multiple buoys. And it's the same with substorms, except instead of buoys in the ocean, the Themis mission is using satellites. The goal of the mission is to figure out exactly where substorms start. And once every 4 days, the satellites enter the region of space where substorms occur. The Themis mission is operated at the University of California at Berkeley. What am I looking at?
Now you can see...
I see the Earth in the middle.
That's right, and the 5 satellite orbits off to the right. This covers 4 days worth of orbit track.
And it's very clear when they all line up.
Exactly.
Themis is named for the Greek goddess of justice, that blindfolded lady that holds the scales on courthouses. And just as the goddess weighed competing explanations to determine the truth, the Themis mission will try to determine which of two competing explanations for substorms is correct. One theory locates the trigger for the violent release of energy relatively close to Earth. The other places that trigger much farther out in the magnetic field. The evidence will be gathered by huge antennas on each satellite. And to see how they packed 5 of these into just one rocket, I paid a visit to one of the guys who designed them. So where have you brought me? What is this place?
Well, so this is the mechanical engineering lab.
One antenna was designed like a kind of high-tech jack-in-the-box. It was nicknamed the Death Spike, for reasons that would soon become obvious.
And when I pull this string, it's going to release.
Can I give you a countdown?
Yes, go ahead.
Okay, ready? 5, 4, 3, 2, 1. Whoa.
So as you can see, about 10 foot up.
And with these antennas deployed, the team hopes the satellites will be in the right place at the right time to catch a substorm in action.
It's like we've laid this trap. We've gone to the jungle and we're waiting for the tiger.
And missions like Themis come not a moment too soon. The sun works on an 11-year cycle. Its activity level rising and falling with the number of magnetic disturbances called sunspots visible on the surface. Over the years, people have tried to link the sunspot cycle to everything from skirt lengths to stock prices. But one thing we know it does relate to is space weather. And right now we're entering a new solar cycle, which will peak between 2011 and 2012. Meanwhile, key data rests on Themis snaring a substorm. And not just any substorm. The 5 Themis satellites line up only once every 4 days in Earth's magnetic field, so the timing has to be just right. It'd be fun to be on one of these satellites as you sort of come into alignment.
And watch one of these auroras break up at the same time.
No, I don't want to be there for that. It takes 2 days for all the data from the outermost satellite to download to Earth. And in previous alignments, the team's already been lucky, snaring several substorms.
This is when the 3 substorms took place. One took place here, the next one about an hour later, and the next one about yet another hour later.
So it's these peaks.
These peaks.
That's the bleeding edge of the frontier of science.
That is exactly right.
They thought it might take years. But just 3 weeks after I left the Themis team, the satellites discovered the smoking gun. A huge substorm that unmistakably showed where these violent releases of energy are triggered. So which theory was right? Was it a huge energy release near Earth? Or a big explosion far away? And the verdict is far from Earth. It's data that will improve space weather prediction and has solved once and for all the mystery of what makes the aurora dance.
Uva ugoni pat tioyat, ilani aturulut, ilani tusang naktok ni pat, ilangit inyupet okaperurot animelanun iligoranun inyusakanipluwich, nagaka ingilangan piaksot, sivulengisa pitkutinipluwich, uva ugoni pat tioyat, ilani aturulut, ilani tusang naktok ni pat inyuk aputmi pisukatakdotun. Doduk tutin Nova Science Mik akupak.
Now for some final thoughts on the Northern Lights. Who would have guessed long ago what causes the aurora? Countless atomic and subatomic particles released by the sun in resonance with its 11-year cycle stream among the planets at speeds up to 1 million miles an hour. These charged particles see and respond to Earth's magnetic field. The positive and negative charges split north and south. They then gather and pulse in ways still mysterious as they collide with molecules of Earth's upper atmosphere. The collisions render the air aglow, creating one of the most colorful and striking sights of the Arctic night, as the sky fills with dancing curtains of light. No doubt about it, the aurora is complex. To understand it requires a branch of advanced physics called magnetohydrodynamics, a field that's been known to make strong men weep. Meanwhile, aurora has been and continues to serve as a fertile source of art, mythology, and legend among Arctic peoples and their visitors, as it leaves viewers in silent awe of its majesty and beauty. It's a curious thing about the universe. Behind the most stunning phenomena to behold lies some of the most challenging problems in astrophysics. From the colorful turbulence within planetary atmospheres, to stars in the throes of death, to the majestic patterns of spiral galaxies, to the large-scale structure of the universe itself. What distinguishes the aurora among them is that you don't need a telescope to see it, just your eyes and a ticket to the Arctic. And that's the cosmic perspective. And now, we'd like to hear your perspective on this episode of Nova Science Now. Log on to our website and tell us what you think. You can watch any of these stories again, download audio and video podcasts, hear from experts, and much more. Find us at pbs.org. That's our show. We'll see you next time.
This Nova program is available on DVD. To order, visit shoppbs.org or call us at 1-800-PLAY-PBS.